today's class, I'd like to talk about two topics from our sessions last week. The first one being that there were three forms of linear equations and that we are able to transform one to another, point slope to slope intercept to slope intercept to standard. We should be able to, like I said, transform one form to the other. So if I give you a slope and a point, m is equal to 4 and the point is 3, 7, we can start off, if we'd like, by writing this in point slope form. We could also start by writing slope intercept form. We can use either one of those first two given this information. But I'll start with point slope. We have our x1, y1, so we have y minus 7 equals 4 times x minus 3. We substituted in the x and the y and the m. Now I can take this is now point slope form. Point slope. We could now take this and transform this to slope intercept. How would I do that? I would take this equation and I'd start by distributing. Now you only do this if you're asked to do this. If you're not, you're just done with point slope with that first box there. I have to isolate y by adding 7, and now I have y is equal to 4x minus 5. This is now slope intercept form. If I wanted to take slope intercept form and write this to standard form, I would then have to move my variable term over. X's and Y's need to be on the left. So if I have this initial equation and I subtract my 4x on both sides, I will have negative 4x plus y equals a negative 5. However, we said there were two forms of standard. If I wanted to, I could multiply the entire thing by negative 1, and I'd have 4x minus y equals 5. Both of these are the standard form of that equation. Point slope, slope intercept, standard form. You're able to take the information given and write each of the forms. Let's look at a second example. We'll start with point slope again. Y, it seems to be the most direct. If I do slope intercept first, I'd have to find my y-intercept and then start rearranging. So it makes, I think, good sense to start with point slope. Y minus 5 equals negative 2 times x. Now remember, when I have a negative coordinate, I add the opposite, so I get plus 4. This is my point slope form. Point slope and done, okay? But if I ask you to take point slope and convert that to slope intercept now, I have to get it into y is equal to mx plus b. So we'll distribute. We'll get y minus 5 equals negative 2x minus 8. To get y isolated, we will add 5, and we'll get y is equal to negative 2x minus 3. This is now my slope intercept form. Y is equal to mx plus b. If I want to take this now and convert to standard, okay, to get this to standard, I'm going to add that 2x over, and I'm going to get 2x plus y equals negative 3. And there's my standard form. 3 different forms given the slope and a point, easy to do the transformations. I'll try one more, or maybe I should say you should try one more, and we'll check to see how you did. We can start with point slope form. In point slope, I'm just replacing things, and that's why I say this is probably a little bit easier. Y, I have a negative coordinate, so add the opposite will give me 6. I have a slope of 5. And x, since this is also a negative, negative minus a negative will give me a plus. We add the opposite. And there's my point slope form. Slope intercept is my next. What will I do? I'll distribute. I'll subtract 6 to isolate y. And here is y is equal to 5x plus 4. Slope intercept. Lastly, let's do standard. Standard is my ax plus by equals c. So I move my x term over by subtraction this time. If I wanted to, I could leave it like this, but there's a second form with a leading term that's positive. So there are always two standard form variations here. These are both the standard form of this equation. And there you have your three forms. The other thing we focused on in our last class was parallel, perpendicular, or neither. And if we recall, we talked about parallel lines having the same slopes but different y-intercepts. Perpendicular lines have slopes that are opposite reciprocals, so we change the sign and flip. And then we have neither, which have no relationship with their slopes at all. We were able to write equations based on given information. If I tell you that there is a line parallel to y is equal to negative 5x plus 1, and it passes through the point 2, 3, we can write that line. We need just the slope, so we need m is equal to negative 5. We can now write it in slope-intercept form, but we need a y-intercept. So this now we're back to y is equal to mx plus b. So I have 3 is equal to negative 5 times 2 plus b. 3 is equal to negative 10 plus b. And lastly, we'll add 10 to both sides, and we'll find our y-intercept is 13. So the line that's parallel to this would be y is equal to negative 5x plus 13. Here's a second example for you to try, and we'll review that one in our session. So give it a try. And the last thing I want to review is our perpendicular lines. And perpendicular lines have slopes that are opposite reciprocals. Change the sign and flip. So in the given equation, m is equal to 1/2. For the perpendicular that I'm going to use, I need m is equal to negative 2. Change the sign and flip. So we have y is equal to negative 2 times negative 4 plus b. 9 is equal to 8 plus b. We'll subtract. We find out that b is equal to 1. Now I'm going to use this new slope because it's perpendicular, so y is equal to negative 2x plus 1. And as in the last slide, here's a second problem that we'll do in class, but if you have a chance, try it before I reveal the answer. And that's all I wanted to review for our session today.